Assistant Professor, Science and Humanity Department, Emmanuel Research JJ College of Engineering, Natala. Now we discuss about the small topic is the magnetism. The magnetic the classifications of magnetic materials are diamagnetic materials, paramagnetic materials, ferromagnetic material, antiferromagnetic materials. Magnetic materials having two types, atoms having no permanent dipole moment. Another one is atoms having permanent dipole moment. Okay. Which magnetic material is no permanent dipole moment? The diamagnetic materials are called the atoms having no permanent dipole moments. Paramagnetic, ferromagnetic, antiferromagnetic and ferrimagnetic materials the atoms having the permanent dipole moments. First I explain the magnetic susceptibility, the magnetization, the relative permeability, then magnetic flux, magnetic field intensity H, permeability, magnetic flux density. Then the magnetism is called as nuclear spin, the spin of electron, orbital motion of electrons. The nuclear spin means weak effect. The spin of electron means unpaired electrons for net magnetic moments. Orbital motion of electrons, this is the strong effect of the magnetism. First one is the diamagnetic materials. The diamagnetic materials they exhibited by all the materials. The atoms in diamagnetic material do not possess the permanent magnetic moments. However, when the diamagnetic material is placed in an external magnetic field, the electrons in the atom's orbit tend to contract the external magnetic field. Hence, the atom occur an induced magnetic moment. As a result, the material becomes magnetized. The direction of the induced dipole moment is opposite to that of externally applied field. Due to this effect, the material is very weakly repelled in magnetic field. This phenomenon is called diamagnetism. When the magnetic field is H is 0, the atoms possesses the zero magnetic moment. When a magnetic field is applied in the direction of the force, the atoms acquire the include magnetic moment in the direction of opposite that of the magnetic field. The magnetic susceptibility is small and negative. The relative permeability is less than 1. It is present in all the material, but since it is so weak, it can be absorbed only by other types of magnetism. So totally it is absent. The examples of diamagnetic materials are water, gold, mercury, ions like sodium ion and chloride ions, etc. The next one is the paramagnetic material. What is paramagnetic materials? Paramagnetic materials. In certain material, each atom or molecule possesses a net permanent dipole moments, even in the absence of external field. The magnetic moments are randomly oriented, means H equal to 0. The alignment of magnetic moments with the external magnetic field is H. The magnetic moments are randomly oriented in the randomly oriented in the absence of external magnetic field. But in the external magnetic field is applied, the magnetic dipoles tend to align themselves in the direction of the magnetic field. This effect is known as the paramagnetism. With increase the temperature, the increase in thermal agitation disturbs the alignment of the magnetic moments. Next one is the ferromagnetic. What is ferromagnetic materials? The material which exhibit the ferromagnetism, the material which exhibit the ferromagnetism are called ferromagnetic materials. All the dipoles are aligned parallel to each other due to the magnetic attraction between the dipoles. They have the permanent dipole moment. They strongly attract the magnetic field. They exhibit the magnetism even in the absence of magnetic field. This property of ferromagnetism material is called spontaneous magnetization. They exhibit the hysteresis, then on heating they lost their magnetization slowly. The dipole alignment is shown in the figure. Okay. Next one is the domain theory. The domain theory of ferromagnetism. The group of atomic magnetic materials. The group of atomic ferromagnetic materials. The permanent magnetic moment aligned in very tiny region in the ferromagnetic materials are called magnetic domains. The actually domain theory explains the ferromagnetic material. The ferromagnetic material contains a large number of domains. In each domain, the magnetic moments of the atoms of the the domain behaves like a magnet with its own magnetic moments and axis. The demagnetized ferromagnetic materials, the domains are randomly oriented. The boundaries separating the domains are called domain walls. The boundaries separating the domains are called domain walls. However, the domain wall are thicker than the grain boundaries. When the magnetic field is applied externally to the ferromagnetic material, the domain align themselves within the field. Then the process of domain magnetization, the two types, by the motion of domain walls, by the rotation of domains. First one, the motion of domain walls means when a small magnetic field is applied, the domain with the magnetization direction parallel or nearly parallel to the field. Next one is by rotation of domains. The magnetic field is increased to the large value. Further domains growth becomes the impossible through the domain walls improvement. Antiferromagnetic materials. Antiferromagnetic materials. Antiferromagnetic materials are magnetic material which exhibits a small positive susceptibility of the order of 10 power minus 3 to 10 power minus 5. The susceptibility increases with increasing temperature and then reaches a maximum of certain temperature or called Néel temperature Tn. Okay. Antiferromagnetic material. In the paramagnetic state, the variation of inverse susceptibility the temperature is linear. Then next one is ferrimagnetic material. Ferrimagnetic. What are the ferrimagnetic material? It is another name is ferrites. The materials exhibit the ferrimagnetism. Materials exhibit the ferrimagnetism are called ferrimagnetic material or ferrites. The properties of ferrites. The ferrites has net magnetic moments. The susceptibility of ferrite is very large. The ferrites has net magnetic moment. Above Curie temperature it becomes the paramagnetic. It behaves a ferrimagnetic material. Below the Curie temperature, the susceptibility of magnet ferrite is very large and positive. It is depend on the temperature. Mechanically it is pure ion character. They have high permeability and high resistivity. They have low eddy current. They have low eddy current loss and they have high permeability and high resistivity. They have low eddy current loss and low hysteresis loss. Okay. The structure of ferrite. The structure of ferrites means the regular spinel. It classified the types of structure of ferrites. Regular spinel, inverse spinel. Two types. The regular spinal structure means each relevant metal ion is surrounded by oxygen. The oxygen ions is a tetrahedral fraction. The applications of ferrites. First one is the manufacture of permanent magnet, production of cores, magnetic films. Next one is the magnetic disc and taps. These are the applications. The production of ultrasonics. The production of ultrasonic waves. Then radio receiver, gyrator and a circular and insulator. Okay. Applications of ferrite. The manufacturer of permanent magnet. The hard magnetic ferrites are used in the manufacture of permanent magnets. Then production of cores. The soft magnetic ferrites are used in production of cores. Magnetic films. This technology is important for electronics, automobiles and computer hardware engineering. Magnetic disc and taps. The ferrites are used in information storage device such as magnetic disc and taps. The production of ultrasonic waves. The ferrite rods are used to produce ultrasonics by magnetostriction principle. Radio receiver. The radio receiver are used in the increase the sensitivity and selectivity. The ferrite rods are used in radio receiver to increase the sensitivity and selectivity. Then gyrator, circulator, isolator. Since the ferrite has low hysteresis, the low hysteresis loss and eddy current loss, it is used in two part of what is the soft magnetic materials and hard magnetic materials. The magnetic materials are two types. One is soft magnetic materials, another one is hard magnetic material. Materials which are easy to magnetize and demagnetized are called soft magnetic materials. Materials which are easy to magnetized and demagnetized are called soft magnetic materials. The properties of soft magnetic materials. First one is the hard magnetic and soft magnetic. Soft magnetic material. Materials which are easy to magnetized and demagnetized are called soft magnetic material. Properties of soft magnetic materials. They have high permeability. The soft magnetic materials can be magnetized and demagnetized easily. They have high permeability. They have low cohesivity. They exhibit low hysteresis loss. The magnetic energy is stored in flow. This is the properties of soft magnetic materials. Next, the applications of soft magnetic materials. The cast iron. The cast iron is used in the structure of electrical machinery and framework of DC machine. Then carbon steel. Then used as silicon steel. It is used for the construction of poles. Manganese and nickel steel is used for making cable boxes, meter boxes in the மாதிரி. Next, perminar, permalloy. These are the applications. Next one is the hard magnetic material. The hard magnetic materials which retain their magnetism and are difficult to demagnetize. The material which retain their magnetism magnetism and or difficulties the demagnetized are called hard magnetic material. The properties are they have high retentivity and cohesivity. They have large hysteresis loop area and hence large energies loss. Are the examples of hard magnetic materials: the tungsten steel, cobalt steel, alnico, hypernic. Then the applications of hard magnetic materials. The tungsten steel is used in making the permanent magnets for dynamos and motors. Cobalt steel is used in motor, fans and heavy duty instruments. is used in this, the design of a portable and light-weighting instrument. Alnico is used in the production of magnetic moment on the smaller size. Difference between soft and hard magnetic materials. Soft magnetic materials, it can be easily magnetized and demagnetized. Hard magnetic material, it cannot be easily magnetized and demagnetized. They have high permeability. The hard magnetic materials they have low permeability. Magnetic energy is stored. The magnetic energy is stored in the soft magnetic material. The magnetic energy is stored in high. Low hysteresis losses the soft magnetic material and large hysteresis losses. Coercivity and retentivity are small. Coercivity and retentivity are large. The domain walls are easily moved. The domain walls are hard to move. The examples of soft magnetic material is iron, silicon alloy, nickel ion, silicon steels and ferrites. The examples of hard magnetic materials are tungsten steel, cobalt steel, alnico and cobalt steel. The soft magnetic material used in the temporary magnets, electric motors, generator. The transformers are called the soft magnetic material. They are used in the permanent magnets, loudspeaker and the electrical measuring instruments is called the hard magnetic materials. This is the difference of hard and soft magnetic materials. Okay, thank you.